have completed this part, that stability of emulsion, where creaming, sedimentation, flocculation, fluorescence, and phase inversion is already covered by me. Uh, next, uh, next here, this is an image where mechanisms of emulsion instability is clearly shown. See, if we assume that it is an oil in water type emulsion, and this is an water in oil type emulsion, then phase inversion, after occurring the phase inversion, this oil in water type emulsion is changes its phase and it converts to into water in oil type emulsion. This is called phase inversion. And see here, if creaming is occur, that means the upward creaming, the oil globules. Already we assume that this is an oil in water type emulsion. So here oil globules are goes to the upward, or the movement of upward uh, of these globules are occurring here. So creaming creaming is occurring. Then next is sedimentation, where the globules are movement, and movement is occur, that is downward movement of the of that globules, which is called sedimentation. And here this is flocculations, that one or two globules are comes closer to each other and floccules or the flocks are formed. And here this is an picture of coalescence, where two or more than two globules are attached to each other and forms a big globule. So coalescence is occurring here. And this is an picture of breaking. Breaking means what? The oil part and watery part is totally separated from each other. This is called breaking. So all you uh, understand the total mechanisms of emulsion instability. Then comes to this point, that this is very important for choosing an emulsion or identify an emulsion. Uh, but appearance and identification is done by this following tests, like dye solubility test, dilution test, conductivity test, and creaming test. So here the dilution test. In case of dilution test, if we add uh, continuous phase to any type of emulsion, then no breaking is happen there. Like if we if we take an oil in water type emulsion, that means oil is in dispersed phase and water is in continuous phase. So if we added water into it, then no phase change is occurring here. That means it remains stable. No phase is changing here. But if we dilute it with oil, then phase is changing here. See, and here also the same things. This we assumed, if this is an water in oil type emulsion, that means where oil is in continuous phase, and we dilute it with oil, then no phase is changing here. And after adding the water, phase change is occurring. So by dilution test, we can easily identify and emulsion, whether it is oil in water type or water in oil type. Now come to the dye solubility test. If we take a dye which is water soluble, and we mix one or two drop dye into the emulsion, if the whole phase is and after mixing the dye, if we take some part of emulsion and place it on a slit, that means microscopic slit, and under the microscope, we can see that if the continuous phase is down into the colory part, or with the dye, and the globules are remain uncolored, then it will be an oil in water type emulsion. And if we take a dye which is oil soluble and mix it to the to the emulsion and uh, take its part, a small part of its under the microscope or microscopic slit. And if the globules only turn red, then we have to assume that it will be water in oil type emulsion. Sorry, if water in oil type emulsion only globules turns red, and the dye is soluble to the water only, then globules only turn into red. Then we have to assume that it will be and water in oil type emulsion. Next comes to the electrical conductivity test. We all know that water is an good conductor. So where the water is a continuous phase, that means the oil in water type emulsion. If we dipped an electrode into the emulsion, then if the bulb glows, then we have to decide that that is an oil in water type emulsion because water is a good conductor. But in case of water in oil type emulsion, the bulbs does not glow. Okay. So by these changes, we can assume the or we can conclude that which is the water in oil type emulsion and which is oil in water type emulsion by electrical conductivity test. Here is a schematic of mechanism leading to coalescence and of an oil in water type emulsion. See first, this is an original emulsion, then sedimentation occur. This is oil and water interface. Okay, here this proportionation is occurring here. Here creaming the upward movement and sedimentation, that means downward movement. Then flocculation is occurring here. Okay,